I'm Andrew Devitt from the Property Care Association, and we're looking forward to this webinar this morning. But just trying to give you some background to who the Property Care is. The Property Care Association is the UK's leading representative organisation for the building protection industry, and our trained and skilled and audited membership operate across all the domestic, commercial and the civil sectors in the structural repair, structural waterproofing, and also timber preservation, damp protection, flood remediation, and not forgetting our invasive weed control industries. Now, the PCA is focused on the complete building envelope, and our members' expertise helps protect the integrity and comfort of building and homes in the UK. Our member also deliver cutting-edge techniques to provide commercial and civil structures against water penetration and ground gases. So for those joining us today who are outside of our membership, the PCA has the ethos to promote excellence by ensuring that our members adhere to strict criteria, including that they are working to the latest guidance and best practice and have qualified and skilled staff. So ongoing biannual audits of contractors and independent surveyors companies ensure all aspects of their business operate to the highest regulatory standards. And this involves checking company systems and procedures, health and safety practices, and staff development and training programs. And we also help owners to access our contractors and surveyors and raise standards with the industry by offering training and developing to all. So the PCA also supports opportunities for continuing professional development, and like our presentation today, to ensure the maintenance and development of both knowledge and skills within the industry. So today's webinar is focused on the structural waterproofing sector. And recently the PCA have revised the best practice guidelines to below ground structures related to buried roofs. And this document is available for download from our website. So I'd like to introduce Ben Hickman from CSSW London, and he's going to provide us with a structural waterproofing design perspective and overview of this guidance document and its practicalities, in both the designing and installation principles for buried roofs below open air amenity spaces. So Ben, I'd like to hand over to you now for your presentation, please.
Thank you, Andrew. Good morning. So what is a buried roof? Well, it's some sort of a roof-like structure, and to the left there I've shown the Louvre in Paris, and you can see what it looks like above ground and below ground. And then to the right I've shown, I believe this is Bloomberg's headquarters in London, and at street level it looks like this, and below ground it looks like this. And that red line is it's the structural element that separates the elements from occupied space beneath. And thank you to AKT2 for use of that image. Here's another podium deck picture that I took right near St Paul's Cathedral in London, and this is a ground level structural element, and below you can see some sort of accommodation occupied space, and above ground it looks like street level, public realm. You may well be familiar with this sort of image, which is common in Victorian cities, and there are these things, smoke vents or pavement lights, and actually the basement line is this sort of line where the basement goes beyond the superstructure. And just an aside on this, Dr. Ricky, apologies, I can't remember his surname, but he's going to be covering some of the nuance of fire and water and the interaction between them in the waterproofing conference next month in November. So there's an interesting history there between fire and smoke vents and things like that, and waterproofing, because these are really challenging waterproofing elements. Here's another image, also in London, taken from street level, and you can see there's something of a fire escape there, and this is a buried roof. And here's another image of the same development. So between all of these buildings, there is a common basement, and this here is a buried deck. interesting that you've got a MEWP on there. So you wouldn't often see a MEWP on a third-story roof. And there's an interesting nuance and challenge there about, well, how do we waterproof things and what impact would that have? A couple more examples. Below this lawn is a car park. And so again, you have a buried roof at ground level. Here's a really strange one. This is a swimming pool and this is a river. And under the swimming pool is a basement. And actually at this sort of line, you could be walking within the service area. Really interesting, challenging components of, well, how do you waterproof this? And we're waterproofing it from the river and the swimming pool and the buried deck. You get some challenging structures. Here's one last one. And this is a very lovely, relatively new home. And from this line back, there is a basement under the structure, and the buried roof in this area is very heavily trafficked, which creates some significant waterproofing challenges. So there's a quick kind of example of lots of different buried roof structures. So here's the agenda for the next hour or 55 minutes. I'll give a tiny little intro. We'll talk about some of the best practice guidance, and then we'll cover some of the design principles. And I'll touch on some of the challenges. I'm afraid I won't cover very much of the challenges. I'll see what time there is for case studies, and then there will definitely be some time for questions and answers. However, if you'd like to ask any questions as we go, feel free to use the chat. I see that works. So my name is Ben Hickman. I'm currently the chair of the PCA, although very soon I'll be handing over to Emily Walker, who many of you will know. She's excellent at waterproofing and will be a great addition to the PCA as well. I'm the founder of CLW, and this week has been really exciting. We've had Andrea start as our practice director. So I've got a team that I'm really, really proud of. Andrea's an architect. Johnny's a structural engineer. Alan's an architectural technologist, and I've got various sort of backgrounds. So a team of 4 very accomplished and qualified waterproofing consultants. We love working on big, complex basement waterproofing schemes. There's a QR code there that will take you to my LinkedIn profile, which is sort of my social media poison of choice. I'd love to connect with you there. And Vector is another company that I co-own, and we do really complex leak detection. And a lot of that's to do with basement podiums. And so that's why I'm mentioning that, and I'll cover some more of that later. I was on the committee that did the revision of VSA 102. I was a technical author of Series C 817, and that's about blue roofs. I do a lot of expert witness work, and I've got some qualifications. So here's a QR code that will take you to the PCA guidance document. Apologies, I don't know how to mute that. That might do it. Apologies for the background noise there. So PCA guidance document is about buried roofs below ground, and I didn't write it. I contributed some of the content to it, but really it's thanks and congratulations mostly to Andrew. And Andrew sat on the shoulders of James, who did the previous version, with a lot of input and support from James Hockey as well at Trace. So I'm really proud of the PCA and the role that we take in advancing best practice and setting standards and doing good. You know, it's a lot of us interact with people who have failed basement waterproofing, and buried roofs are common. And we want to avoid that. We want to help the rest of the industry and occupants in particular make sure that they have dry structures. So, what is a buried roof, and is that any different to, for example, what's here is a green roof, a really complex green roof, and that is a roof, and it is buried. There is a sort of planting of some sort on top. Here's another building element, and it's buried, it's a tunnel, and it's got a roof kind of structure. Is that a buried roof? And here's another example of a commercial premises in the brick arch vaults of a railway bridge. And are those buried roofs? Sort of and sort of not, and it's difficult to differentiate and to define, but there are certainly elements of a roof, and the roof primarily is a structure that it protects the rest of the structure from the elements, and particularly water. And all of these structures are doing that, and buried roofs below ground level are also doing that. However, there's some nuance and some difficulty and challenges. And here's an example. This is an AI generated image, but because buried decks at ground level are at ground level, it is feasible in lots of circumstances that you might have, for example, an emergency vehicle. And the dynamic loading that introduces is really quite significant. How do you design for that? I showed an image previously that had a MUP on it. Now, obviously, that introduces loading that you wouldn't necessarily plan for. And that loading goes all the way from finishes through potentially drainage layers and things like that, through to the structural deck. That brings in some challenges and difficulties. And here's another kind of challenge and difficulty at ground level that you don't have on roof structures, which is flooding. And surface water flooding in cities where you get a lot of these structures is increasingly common, and brings some real challenges about how do we waterproof these structures. A couple of last ones. On the left there's a gentleman pressure washing the pavement, and that's actually a podium, and it's a buried deck. Below that is a basement car park. You might get that on a roof, but it's quite unusual. And then to the left here, it's not a great image, apologies, but this is an image taken from 3 stories up, and that very mature tree, and that one as well, is on the basement buried roof podium. So below those trees is basement structure. And that level of mature tree would be very rare on 7 stories up on a building, despite lots of the kind of eco and green images that you might see across the world on built environment would have a lot of greenery and trees. Very rarely would you have that level of mature tree on a roof. So best practice guidance, I've mentioned PSA 102, so that's the guidance on below ground structures, protecting below ground structures from water ingress. BS 6229 is about flat roof structures, and there's a lot of comparable and relevant information there. This PCA guidance is very relevant. And I mentioned blue roofs because there are some similarities there, and very often a blue roof is placed on a ground level buried roof. So if we start with PSA 102, we would often begin, well, we should begin with a desktop study and looking at the structure. And then very importantly, well, how dry do we need that space to be? What's the grade of waterproofing performance? And this image is of a very, very posh environment that obviously needs to be dry. This image is of a very rough environment that perhaps doesn't need to be dry. That's a sort of a London Victorian coal chute, coal store space. Does that need to be dry? You could debate it. Here's a similar structure, and it's got some type A cementitious waterproofing, and it's containing some plant space. Is that performing adequately? There's condensation up on the soffit. Maybe, maybe not. And here's the same structure in a slightly different setting. Is that performing adequately? How dry do we need that to be? I laughed when I saw this on site because there's this very bizarre dog skeleton. But you can see there has been some ingress through the cementitious type A system. But what really caught my eye is that there's this fire compartmentation that's clearly been damaged by the water. And if I zoom in a little bit, there's your fire compartmentation and the dog skeleton. And the seal, the fire compartmentation people have put a sticker next to the seal saying, if this is damaged, please report immediately. And again, the fire component is very significant when it comes to these buried roof waterproofing elements. And so when we ask ourselves, how dry do we need this to be? Often it's not as simple as, you know, the finishes, which is how I would normally think about it, or you know, if it's a plant space, maybe it doesn't need to be quite as dry as the posh residential below ground space. Fire compartmentation, if that's getting wet, that can have very serious implications, and post Grenfell we should all be very aware of that. You know, this is a basement car park. To the left here, does it matter if there's a bit of water coming through a basement car park soffit? You could argue perhaps not. Cars are designed to have some rainfall. That's not the end of the world. But because it's dropping all of these minerals, actually that is a challenge, and those minerals damage car park paints, and, you know, this is forming trip hazard. Here we've got buried deck soffit and a Heath Robinson gutter that's trying to take the water away, but all the minerals are damaging this. I think it's a vent and the copper on this pipe as well. And then on this image, we've got a steel frame structure, and we've got fire protection for the steel frame that has got wet and is actually coming off down here. And if you were to combine the risk of perhaps an EV, an electrical vehicle fire, which is very high temperature, very hard to put out, with a below ground space, so there's very little room for heat to dissipate, and a steel frame structure where the fire protection, is damaged, that's really quite concerning and could lead to rapid structural collapse, for example. And so when we think about what's the grade of waterproofing performance we need, I would urge us all to think about fire and other fixtures and fittings. I've been called to one where the fire alarm system was being damaged by water dropping onto the fire alarm sensor. And so the fire alarm was going off all the time on this commercial premises. That was having a big impact. And lastly, in terms of kind of how dry do we need it to be, here's an image of there's been water ingress through the buried roof soffit, and this white is a localized internal gutter system trying to take water away so it's not dripping on the cars. And you can see that's what's coming through here. There's lots of leaching from the concrete. And if you leach lots of minerals out of the concrete, you lose the passive protection, and then the rebar can corrode, and that can cause spalling. So you've got popping of concrete on a structural element that has significant punching, I think it's called punching forces. So again, structural implications. So how dry do we need it to be is a very important consideration. What else matters when we think about waterproofing design? Well, here is an image from the PCA guidance document, and you can see the complexity. There's lots going on here. And so we've got a deck that's cast to falls. We've got a waterproofing layer. We've got a drainage layer. We've got a land drains. Land drains need to be able to discharge somewhere with permission. That's tricky. It needs to be maintained. All of the nuance of, well, how do you terminate this and interface with the DPC? This doesn't have any insulation, so is there a condensation risk? So there's lots of complexity to a buried roof system. But one that I want to highlight is the challenge of traditional design teams would have a lead designer for the substructure, which would normally be the structural engineer, and that's to do with the foundations. And a lead designer for the superstructure, and that would be the architect normally. And so if you've got somebody who's owning all of the design responsibility and the coordination for above ground and the substructure, you can often get this gap where between the top of the capping beam and ground level, you don't actually have a lead designer. And that's where all of this waterproofing design is occurring for a buried roof system in most situations. And so it's a a matter of a lot of significance and has a big impact in our world. So what is the design philosophy? I think firstly I'd want to point out that we need to have a waterproofing specialist, and BS 8102 highlights this with, so this would be particularly for a cavity drain system installed to a soffit, but inverted applications are deemed to be higher risk, and therefore specialist designers and installers should be included from the outset. So there's a particularly high risk element, and that's highlighted in BS 8102. And this PCA guidance document also highlights the need for a waterproofing design specialist. Sorry, that's my spelling mistake there. And then also in BS 8102, we've got the clause 4.2, and a waterproofing specialist should be appointed. And that's a very important word. It's very kind of contractual sounding. And you know, a contract is offer plus acceptance plus consideration. And that's very important for the end users and the clients. Not only was a waterproofing specialist somehow involved in advising on the waterproofing design development, but they actually are appointed, which means they're responsible, and there's a recourse there if they gave some bad advice. And this mentions appointed at REBA stage 3. I would actually highlight, it'd probably be better to have them in the REBA stage 2. I also want to point out this this concept of there are things that we know, and there are things that we know that we don't know. But there's this very kind of interesting element of there are things that we don't even know that we don't know them. And all of our professional standards or codes of conduct would be very explicit that we should only do work that we are competent to do. We shouldn't go beyond the area of our expertise. And on buried roofs, I see a lot of architects in particular taking on the design development, and I really, they're not waterproofing specialists, and they don't even know that they don't know some of the issues that are at play here, and that's a very risky thing to do, and something that I would urge you to not do. Really, you should appoint a waterproofing design specialist. I also just want to labour some of the contractual risks. It's very important that we are aware of these, because I don't want people to get into difficult situations with claims of professional negligence. I mentioned that I do a lot of expert witness work. I was recently on a call with 2 solicitors and a barrister as they prepare some of their documents, and they were asking me about, you know, what is the standard that you would expect from a competent waterproofing contractor, because that's the test for negligence. If you do something that's not even as good as the standard we would expect from a reasonably competent waterproofing designer, that's negligence. And I was explaining to the barrister, well, actually, I think most of the people in the industry wouldn't do X, Y, Z. And the barrister said, well, that's what's called the lemming defense. And the lemming defense is, well, you know, everyone else is doing it, and so presumably that's okay. And legally that doesn't stand up. Here's a picture of lemmings, which, as far as I know, don't actually commit suicide en masse. But just, I would urge you, if you are a waterproofing specialist and you're involved in designing something, the burden on you is really quite significant, and it's not enough to take comfort from, oh, so-and-so does this like this as well. And this has really come to the fore since Grenfell, and the phase 2 report states very clearly this burden on professional designers, where lots of architects were specifying cladding that wasn't actually fit for purpose, and they were relying on BBA certificates. But during the phase 2 report, actually, it's the the outcome has been, well, really they should have read the whole report, the whole BBA certificate, and not relied on specific parts in isolation. And I would urge, I guess I would ask you, when was the last time you read a BBA certificate in full before specifying a product? There's just a little, I guess, reminder to try and say, take this seriously. If you are a waterproofing specialist, be very cautious and think it all through. So what are the principles if you want to design waterproofing for a new build buried roof? And I would summarize it in 4 relatively simple steps. Number 1, we would want a reinforced concrete deck. Number 2, we would want some falls. Number 3, we would want a fully bonded system, and I'll talk more about that in detail in a moment. And then number 4, we would want drainage. So why would we want a reinforced concrete deck? And that's quite a reasonable, legitimate question. And I've summarized some of the things here, and then I'll show you a bunch of images and talk through in more detail. But firstly, we want some durability. So if there is water ingress, what happens? And concrete is more durable than a lot of the other options. We want dimensional stability because that really helps the waterproofing. And we want something that is repairable. And I'll dwell on the repairability quite a lot. Bear with me. I hope that's valuable. So firstly, durability. Here's a picture of a development, and it's into an incline, and the architects come up with some lovely detail about the lawn flows over the structure. And this here is the green roof, but it's a green roof on a timber deck. And I saw that and I was very nervous and thought, oh, I don't think that's an okay design. And they've since changed that design. But here's why, and this image is courtesy of Dr. John Williams. And what we've got there is a CLT deck, and it had a roof on top, and the roof had a leak, and that led to some fungal decay that was quite extensive. Obviously, that's something that is very much something we'd want to avoid. Here's another soffit for a buried roof, and it's a precast concrete plank system. There are lots of gaps in that and lots of potential for movement. That makes the waterproofing very difficult. And if there's ingress, the ingress would come in through the gaps between the planks, most likely, rather than show us where is the defect in the waterproofing. And here's a composite metal deck. I showed you that image earlier. There's a real challenge with composite metal decks where if you get water coming through the podium, it sits within the concrete and sits on top of the permanent formwork, which is largely waterproof, and then comes out through penetrations or joints. So again, the point of ingress has no correlation to where is the defect in the waterproofing. And finally, here's a reinforced concrete deck, and it's dimensionally stable, and it's durable, and it's potentially repairable. And we'll talk about that in a second. I'm just going to take a swig of my tea. So we want a reinforced concrete deck, and we want falls. And I just wanted to labour, there seems to be a lot of misunderstanding about zero falls. The roofing industry is full of this. It's quite frustrating, where flat roofs aren't flat, and zero falls actually means you need falls. In Series C8 17, we came up with a new term of absolute zero gradient, which means that you need to have a slight gradient. So just be aware, on all buried roofs, you need falls. And even if you find a product that says, oh, you don't need falls, this is approved for zero falls, you still need falls. Back falls are not acceptable, and you need to allow for deflection. So yes, we must have falls, and if there are dips in the deck, they need to be removed. And I would also highlight that outlets often need to be recessed in the podium deck. So here's a deck that doesn't have a lot of falls, and actually it's been designed for deflection to happen once the overburden gets on top of this deck. But the outlet isn't recessed, and so we do have some slight ponding there. And it doesn't matter if you put a drainage layer over that, water's not going to get off it. So we do need falls. However, that's quite complex, and it brings a lot of challenge. Typically, our threshold level will be set by highways and proximity to highways and access, and that's normally a very fixed position. And then we would have somewhere over here a capping beam, and again, that's a very fixed position. And then we would normally have a sort of a services zone, and we can't go below that. And structurally, you would, and cosmetically, you normally want outlets near the columns so that you can hide them. But the point of greatest deflection is exactly midway between two columns. And so we've got to achieve the 1 in 80 fall above the deck. And then also the drainage needs a fall in order to get self-cleaning. All of that is coordination heavy. So that would be a waterproofing designer speaking to the architect, speaking to the landscape designer, speaking to the M&E and the drainage. There's a lot of complexity around that needs coordination early. And I guess it's worth just being aware of. And then obviously we want drainage, and we would all be familiar with, there's a drainage layer in terms of how much drainage, how many outlets. There's BSEN 12056 and some calculations around that, and rainfall intensity and things like that. And then you'd have queries about, well, how much of that water do we think is going to go into the surface water drainage and the ACO channels, and how much will percolate down and hit the waterproofing layer? Lots of complexity, and more complexity to do with maintainability as well. So there are the four elements that we would want to talk about. Apart from, number 4 is the fully bonded is how we would often talk about it, but that's significantly to do with repairability. And in BS8 102 and structural waterproofing, we're all very familiar with that you need to design something that's repairable. And actually the roofing industry doesn't really know that. And I think historically a roof has been, if you have a leak, you go up onto the roof and you fix it. But increasingly, roofs are buried structures themselves, and you would have photovoltaics and plant and green roofs and insulation. And actually, it's very difficult to find leaks on roofs now as well. And there's an increasing pressure to make sure that roof waterproofing is repairable as well. But if you want to repair a buried roof waterproofing system, there are several challenges, but one of the biggest ones is, well, where is the leak? And another one is, well, can we get to it? And potentially, if we have a reinforced concrete deck and a fully bonded waterproofing system, maybe we can pursue a resin injection repair. They're often unsuccessful, and lots of challenges there, but let me dwell on the repairability piece for a moment, if I may. So if we want fully bonded waterproofing, that has to be adhered well to the substrate. And here is me doing an electronic pull-off test to say, yes, this is very well adhered to the substrate. But if it's well adhered to the substrate and the substrate has a crack in it, then the waterproofing has to stretch over that crack. And this crack here is 0.7 millimeters. And here is me showing a very crude experiment in my back garden on, here's fully bonded waterproofing, and that's onto a substrate. And I've created a crack, and then I'm stretching this upper surface with these clamps that are forcing down. And over here, you can see the waterproofing is having to bridge the crack. And if you keep stretching and stretching and stretching, you get something like this. And these splits are holes in the waterproofing. And obviously that is a point of ingress. Now, this product is actually stretched a huge distance, but that's installed in lab conditions. And it's particularly stretchy material as well. So there's actually a real benefit to something that isn't fully bonded, because much more of the material can stretch over cracks. And so we have this challenge here of, there are some benefits to fully bonded, because maybe we can repair it, and maybe we can do some resin injection, and maybe we're more able to say, well, this is likely where the defect is in the waterproofing, and that's likely to correspond well with where does water come in to the structure. But actually a loose laid system that's separate from the structure, more of the material can bridge gaps or cracks and movement, and so there's benefits there. The challenge with something that is disconnected is this sort of thing, where you could have waterproofing at this level, and that could be a loose laid system, and if you've got a defect in this location, water can come through this as void form or insulation and spread all across your concrete deck and find a point of ingress that bears absolutely no correlation to where is the defect in the waterproofing. And then is that repairable? Well, if you can't find the defect, no, it's not repairable. I guess the other challenge is if the defect is there under your mature tree, under a tree planter, can you get to that and repair it? There's a lot of challenge there. So repairability from above, we've got the challenge of, firstly, you've got to locate it, then you've got to expose it, and then you've got to make good. And here's just a kind of an indication of trying to locate a defect in waterproofing, and you're removing different bits of overburden, and you're trying to wet vac out so that you can see the waterproofing layer, and in the process you're disturbing, in this situation, irrigation systems. Here's another one, and that's a blue roof, and the ingress could be anywhere, and in the meantime you're damaging some of the blue roof system, and it's difficult and challenging. And that's what we do at Vector, where we've partnered with an organization in Germany, and we do very complex leak detection, which I'm really pleased with. And we do lots of leak detection in green roofs and things, and we map the electrical flow through these varied structures and say, do you know what, our point of ingress is here, then we can do localized exposure and repair. I also wanted to highlight this because I think it can go unnoticed. In BSA 102, there's quite a clear note that says if you do pursue a warm roof buildup, and as I say, there's a lot of benefits to that, where the insulation is kept warm, you can achieve falls through tapered insulation. If you do take that route and your waterproofing is disconnected from your structure, it's important that you make sure that the leak location is identifiable in order to make it repairable. So permanent leak detection should be employed. Similarly, Syria 817 says the same thing. And again, this is something that we provide at Vector, and there are several different options that I'd love to chat about. So that's all kind of new build design content. I think I'm running a little bit late, so apologies. What do you do if, well, actually it's an existing structure and you can't get down to the deck from above and waterproof from above? And here's an example of what can be between the pavement and the structure you might want to waterproof. There's a lot of utilities, for example. Well, you've got immediate options of type A waterproofing, and I'll come on to type C, but type A, there are significant challenges with movement. And I've already mentioned dynamic loading from, for example, a fire engine, but even if it's just near a road, the consistent movement can be particularly challenging for cementitious systems. And then we have big challenges about where do you terminate that waterproofing, because it needs to finish at some point really above ground level, and we can't necessarily get there. Here's an example of a cementitious waterproofing system, and they are typically very, very rigid. So if there's movement to the substrate, that's going to be problematic. This is one where somebody was trying to install it and there was active water ingress. And so before the cementitious system was curing, water was coming through it. Apologies, I'm going to go pretty quickly there. The alternative is something like a cavity drain system, but you've got to have falls. You can't have a cavity drain system to a basement soffit and not have falls. And in this image here, I'm just pushing the cavity drain system and water flowing out. Issues of butyl tape and really that cavity drain system that needs to be fully supported, and installing that is very challenging. And again, terminations are really awkward around, an entrance, a door frame, or a downstand beam, anything like that. Very difficult to design and install well. Let me race through some other challenges and considerations. Condensation is a huge one and needs to be given a lot of thought. We ought to be aware of vapor control layers, insulation, heating, ventilation. Termination I've mentioned a few times, but that's termination if it's above ground at sort of capping beam level, but then also interfacing with a damp-proof course. You'd want that to be 150 mil above ground level. That gets awkward if you've got a level threshold or a door frame that needs to drain water, any of that sort of thing. Movement joints are always tricky. Maintainability is very often overlooked. How do you get to the different elements and make sure that drainage is maintainable? And then lastly, flooding, which we've mentioned, but is obviously a big challenge. I've taken longer than I intended to with all of that. If I race through a couple of case studies and then I'll hand over to Andy for some Q&A. So here's one case study, and this is a ground floor buried roof with hard landscaping and some planters. And this is the kind of build-up that we're looking at. It's a reinforced concrete deck, which is installed to falls, which is as it should be, had a fully bonded waterproofing system, but no drainage layer. And so if you dig into that system, you see actually there's a lot of water hung up within the bedding mortar because there's no drainage, there's nowhere for the water to go. And as a result, water's coming through the deck with a lot of minerals and leachate, leaving stalactites and things like that. Many of us will be familiar with this sort of Heath Robinson kind of trying to catch water ingress and the cracks in there. Andy, do we have lots of questions? Should I go through another couple of case studies, or should we do some Q&A? We've got 15 minutes left, I guess.
No, you can continue. You can continue, Ben.
Okay.
We've got plenty of time. There's no questions coming at the present time. So yeah, continue with the presentation. That's brilliant.
Great. Okay. Next case study is this sort of scenario, which I guess I see quite a lot in London, where people have extended under their house and then out into their backyard. And here we've got a walk-on pavement light and some nasty flashing around that to try and keep the water out, and a horrible ACO channel detail there and a level threshold through all of it. So it's this sort of arrangement here where the walk-on light, roof light, skylight is there. Then you've got an ACO channel, and then you've got a level threshold door. And the door has drainage weep holes through it that lead absolutely nowhere. All of this is on an RSJ. And this is hung on an L bracket. So, huge potential for movement, horrible waterproofing detail. And it leaked, and we did some dye water testing, and water came in. And I guess I would just, if the audience here is PCA waterproofing contractor members, I would just urge you to be aware of the kind of the design responsibility thing, where if an architect shows you that and you're the waterproofing contractor, it is incumbent on you to either walk away and say this doesn't work, or to say it needs to be fixed. But it's very difficult for a waterproofing specialist to just wash their hands of it and say, oh, design responsibility is with the architect. If you say that you're the waterproofing specialist, as a waterproofing specialist, you should look at that and say, well, that's terrible. We need to do that differently. So just a reminder there. One last case study, and this is a development, and you can drive onto this car park. Under that car park is a basement car park with this sort of construction, the precast concrete planks, and water ingress in leaving very neat lines of mineral deposits. And this is the sort of the waterproofing detail here, where this is ground, and then you can drive from the ground onto this deck. And the build-up there is simply insulation and some nominally reinforced screed, and then a trafficked surface that is also the waterproofing. And that is a lot to ask from a waterproofing product, a product that is so well bonded and durable that it can handle power steering, moving in a stationary place, and it can also handle the potential for cracking. There's conflict between the requirement for stretching and the requirement for robust resistance to movement. Case studies finished. Question time, and if you need any more info, I'll leave you with that QR code.
Thank you, Ben, for that. It just proves to me that a buried roof is a very complex structure in itself, and as you say, there's lots of different nuances with regard to it, and it's not just basically plonking a stable platform and what have you, and putting your amenity space or whatever on top of it. There's a lot of other things which have to be taken into consideration. And I know when we were drafting this particular document, we try to bring all these complexities into it and try and simplify it as much as possible to give that design guidance. But there's one interesting point you brought up here, and that was regard to competency and design responsibility. There is a definite link between there, and you highlighted that point within BS 8102 as well, that there is a level of competency. So what's your view on our structural waterproofers, as to what is the minimum standard basically for competency? How do you see that?
Great question. So I mentioned this conversation I had, it was only a couple of weeks ago, with a barrister. And so I've written my expert report, and then the barrister's going through that. And it actually got to a paragraph where he said, oh, the other side's going to rub their hands with glee when they read that paragraph. And he kind of wanted me to rephrase it so that it would be less helpful to the opposing side, which as an expert you wouldn't want to do, because your duty is to the court and you want to be impartial. But it got us into this kind of long discussion about, what is competency? And I mentioned the test, the legal test is, what would the average competent professional do? If you're below that standard, you've been negligent. And I was saying, well, actually, I think the average waterproofing person probably wouldn't do that. And the guy was like, well, but isn't that just the lemming argument of, everybody does it, so it's okay. And so I guess I've realized it's quite a circular argument, because it's what would the average competent waterproofing designer do? Well, that depends on who's competent. So there's a lot of nuance there, a lot of difficulty. I think I don't know the answer to your question, but I guess my message to our industry and PCA members is exercise a lot of caution, because if something does go wrong and you've got lawyers and barristers looking at it, they don't have a lot of grace. They don't have a lot of room for context, and that particularly the waterproofing specialist contractors, who are often kind of bullied and pushed around by main contractors. You need to be really robust and really clear on, actually, my professional duty of care is to exercise due skill, care, attention, and diligence. And although you might want me to do X, Y, Z, I can't do that. I'm not really answering your question, but I guess I just really want to labour that. Be cautious. I guess that there is mention of the WDS, the Waterproofing Design Specialist, and that's a peer-reviewed register that the PCA holds. So in order to be on the WDS register, you would need to submit 2 reports and have some peers assess you and say, yeah, we think you are a waterproofing design specialist. And I would say if you're not that, then you probably don't want to be doing buried roof waterproofing, because it is so high risk. Yeah,
I agree with you totally on that, Ben, because the experience which I've had within the insurance industry, because it applies to the warranty providers and everything. We talk about the WDS, but it's that competency level of what is a waterproofing design specialist. What level are there? So do they have the, as the SCEB comes out in the BSA, Building Safety Act, with the skills, the knowledge, the experience, and the behavioural aspects, we need to bring that levels up of design responsibility within that to show competence. And I know it's something that the PCA are working on at this present time to try and build up. We talk about CSSW. I know we go back to CSSW, but it is that a sign of competency within this sort of level of expertise which is required. And my view is that it isn't at this present time. CSSW is. I know the CITB are looking at it as well, but it's that trying to raise those standards for waterproofing design specialists. So, yeah. And as you say, it's that design responsibility. If it's above what you feel is you are competent to do, it's best to walk away from it rather than go into it, because it can lead to all sorts of problems and pressures on the individual structural waterproofer. So yeah. The other thing is,
if I can just say something on that, I just want to acknowledge it takes a lot of courage to do that.
It is.
I've run my own little contracting company in the past, and you've got the pressures, and you need to win that piece of work, and you have put yourself out there as a waterproofing specialist to then turn around to your client or an architect or somebody and say, you know what, I don't want to take this on. It's not within my expertise. I just want to acknowledge it takes a lot of courage to do that. But that is part of the behaviours component. We mentioned SCEB, it's the skills, knowledge, experience. The behaviours, I think, is the hardest part to demonstrate. And I've said it before, but I'm particularly proud of the PCA, and that's where something like a trade association really has value, the behaviours element, where you would say, if you're a WDS, you've put yourself forward for peer review, and that being open and willing to be checked by your peers that's the kind of demonstration of behaviors that we need to see. And also, do you know what, if somebody comes across a behavior that's not appropriate, to be able to report that to a trade body, who could then investigate and take appropriate disciplinary action, that is what we need in order to have a whole industry that moves towards greater competence and doing things properly.
Well, that's one of the pursuits of the PCA is really to provide excellence within each of the sectors that we operate within. So yeah, so thank you for that. Just one other one is talking about the comparison between a buried roof and a standard roof. I think you highlighted that point. It needs to be a well-drained structural element, and of course, the key aspect is there. We're talking about structural waterproofing here, but it really goes back to having that knowledge for a stable structure which is well drained. So we talked about zero falls. A zero fall is not a flat surface or anything like that. It is laid to a fall, and so I think that must be get across to all of the industry, where falls must be incorporated into any of these particular structures. So I did quite a lot of work on zero falls roof and what it actually means by zero falls. So I've done a lot of work on the mathematical principles of what a zero fall roof is. So if you want to have a look at those mathematics and what have you, what a zero fall roof is, I'm quite happy to extend that to you. So that's and the one about repairability. I think access to a buried roof is almost impossible. So the interesting aspect of your other company on Vector and trying to identify where these leaks occur, I think that's a fascinating area. I'd like to investigate more in that particular area. So I'll probably have to have that discussion with you a little bit later.
Wonderful.
Great. So there's no questions from those who are on the webinar at this particular time. So we'll conclude it from there, Ben. So thank you very much for your time and your presentation. It's been very informative, and and I think we need to take this a little bit further as well from the PCA's perspective as well. Brilliant. So thank you for that. So just before we go,
let me just say thank you to you as well, and to James and the technical team at the PCA. I appreciate what you do. It's often a thankless task trying to pull together, slightly competing different opinions often. And I know that you've got a very long list of documents that you're working on. But it's really important. It's valuable work, and it makes a difference. So thank you to you and James and Daniel and Harry, all the team there. Thank you.
And just to say, I know I'm struggling with it on the next one, which I'm working on, or the team are working on at the moment, and that's groundwater management. So how do you handle groundwater within basement structures? So that's an interesting one, which it was originally called sumps and pumps, but we were talking about groundwater management. So that's we're taking that another step further, but that's the next one on our list to look at. So before I sign off with everybody, if I just take this off and share my screen. If I can see it now. Okay, so I hope you can see that. It's just a reminder that in November we have our Property Care Conference, so that's all right there. We've got a great list of speakers coming there, and so so we want to try and get all the members there to attend the Property Care Conference. It's informative. We can be interacting with all our peers and what have you, and we can develop new ideas, and it's great to be there. And our guest speakers, which we have, will really promote advances which we're trying to make within the structural waterproofing industry. So if you haven't booked your ticket or place, then please contact Lisa, and we'll get that all sorted out for you. So that really concludes our webinar for this morning. It's exactly 10 o'clock now, and so we thank you very much for your attendance. And if you have any further questions or whatever, please write in, email us, so either myself or Ben, and we're quite happy to answer any questions which you may have. So thank you, Ben, once again, and we appreciate that. So we'll close the webinar now, and thank you very much for attending.
Thanks, everyone. Bye-bye.
Bye-bye.